Welcome to the deep dive. Okay, picture this. You're running a small manufacturing plant, maybe making specialized aerospace parts. Digital's the future, things like machine learning, but, well, hiring experts or building an AI team, it just feels totally out of reach. It's a really common problem for small and medium businesses. So today we're diving into a, frankly, groundbreaking new method that might just change that. It comes straight from the paper, Automated Machine Learning Methodology for Optimizing Production Processes in Small and Medium-Sized Enterprises.
Yeah, and what's really exciting here, I think, is that this isn't just another tool for, building models. This is designed as a complete automated end-to-end process, specifically for optimizing how you actually run production. It really tackles a big gap in current automated machine learning AutoML tools, because the output isn't just a model, it's actual actionable recommendations you can use right away.
Right, so it connects the dots. You mentioned existing AutoML tools. They're good at the model creation part, right? Like prepping data, picking features.
Exactly. They handle the data pre-processing, feature selection, find the best hyperparameters, choosing the right model type, all that technical stuff.
But then there's this gap. You've got the model, maybe it predicts throughput really well, but what do you do with it? Traditionally, you'd still need, a human expert to figure out how to use that model to actually tweak the production line for the better.
Precisely. That's the manual step this methodology automates. Think of AutoML building you a fantastic engine, but then it leaves the engine on the floor. You still need someone to install it, drive the car, navigate.
Okay, so how does this new method bridge that gap? What's the innovation?
The core idea is pretty clever. It takes those machine learning models and generates, say, one predicting output, another predicting scrap, and it embeds them directly into an optimization system, specifically an evolutionary algorithm.
An evolutionary algorithm, like mimicking natural selection to find the best solutions.
Kind of, yeah. It explores lots of possibilities. They use one called RNSGA2, which is great for multi-objective problems. So you can tell it, I want to maximize throughput and minimize scrap, and crucially, you can specify your preferences. It balances those goals based on what's important to you, the decision maker. So the results are immediately useful, tailored.
That preference part sounds key. It's not just giving an answer, but your best answer. Okay, so it sounds powerful in theory. Has this actually been tested? The paper mentioned a case study, right?
It did, yeah. A real-world test with an aerospace component manufacturer, an SME. They were trying to become more agile, needed better decision-making tools, but like you said, lacked that deep ML expertise in-house.
Oh, what happened? Did it work?
The results were pretty compelling. They managed to increase their productivity, their throughput, by an average of 3.19%.
Okay, over 3%. That's not trivial in manufacturing.
Not at all. And at the same time, they cut their defect rate, their scrap, by an average of 2.15%. And this outperformed the traditional methods they were using. It really shows this kind of advanced optimization isn't just for the big players anymore. And is worth noting, this work got partial funding from the European Commission, part of the Fortis project that's multimodal and multi-aspect holistic human-robot interaction.
Right, Fortis. Good to know. So for our listeners, maybe in similar situations, what's the big takeaway here?
Well, it really democratizes these Industry 4.0 technologies. It means companies, maybe like yours, without huge data science teams or massive computing power, can still tap into advanced optimization and see real, tangible benefits.
It takes it from abstract concept to practical tool, removes that need for the specialist translator, in a way.
Exactly. So to sum it up, this deep dive really highlights how smartly integrating automated machine learning with this kind of preference-based, multi-objective optimization. Well, it turns raw data into genuinely actionable insights. It gives you optimal settings for your processes. It's about augmenting human decisions, making them better, faster.
Making knowledge useful, applied knowledge. Okay, so final thought to leave everyone with. If this end-to-end automated approach can redefine efficiency in complex manufacturing, where else could it make a difference? Think about construction, logistics, maybe even areas like healthcare scheduling or resource allocation. What could you optimize with a tool like this?